The universe is vast. Its distances are staggering. Communicating across such distances presents a unique challenge. Imagine trying to hold a conversation with someone across an ocean. Your words would take time to reach them. Their reply would take even longer. Now magnify that challenge to the scale of stars and galaxies. The distances become almost unfathomable. Light itself, the fastest thing in the universe, takes years, centuries, even millennia to travel between stars. This delay makes a real-time conversation impossible. Despite these challenges, the dream of interstellar communication persists. We yearn to reach out, to connect, to share our knowledge and experiences with others who may be out there. The quest to bridge this cosmic divide is a testament to the boundless spirit of human curiosity. It is a journey into the unknown, driven by the hope of discovering something truly extraordinary. To truly grasp the challenge of interstellar communication, we must first attempt to comprehend the immense distances involved. The vastness of space is almost beyond human imagination, stretching our understanding of distance and time to their limits. Our nearest stellar neighbor, Proxima Centauri, is a red dwarf star located a little over 4 light-years away. This distance, while seemingly small on a cosmic scale, is still incredibly vast when compared to distances on Earth. This means that light, traveling at approximately 186,282 miles per second, takes over 4 years to complete the journey. To put it in perspective, light from the Sun takes just over 8 minutes to reach Earth, but it takes over 4 years to reach Proxima Centauri. To put this into perspective, imagine sending a message to Proxima Centauri today. The message, traveling at the speed of light, would take over 4 years to reach its destination. We would have to wait at least 8 years for a response, 4 years for the message to reach its destination, and another 4 for the reply to return. This delay makes real-time communication impossible and requires us to think in terms of years, not seconds or minutes. Now, consider that Proxima Centauri is our closest neighbor. The vast majority of stars in our galaxy are much farther away, some even thousands or millions of light-years distant. Other star systems are hundreds, thousands, or even millions of light-years away. For instance, the Andromeda galaxy, our nearest galactic neighbor, is about 2.537 million light-years away. Communicating with civilizations in such distant galaxies would take millions of years for a single exchange. Communicating across such vast distances requires us to think beyond the limitations of our current technology and consider entirely new possibilities. We must explore advanced concepts like quantum entanglement, which could potentially allow instantaneous communication, or the use of wormholes as shortcuts through space-time. It is a challenge that will require both ingenuity and patience. The pursuit of interstellar communication is not just a technological challenge, but also a philosophical one, pushing us to rethink our place in the universe and the nature of time and space itself. As we continue to explore these frontiers, we must remain patient and innovative, knowing that the answers we seek may be light-years away. Einstein's theory of special relativity established a fundamental truth about our universe. Nothing can travel faster than the speed of light. This revelation not only reshaped our understanding of physics, but also set a cosmic speed limit that governs the entire universe. The speed of light, approximately 299,792 kilometers per second, is the ultimate speed at which all information and matter can travel. This cosmic speed limit has profound implications for interstellar communication. The vastness of space means that even light, the fastest thing in the universe, takes an immense amount of time to travel between stars. The distances are so great that they are measured in light years. The distance light travels in 1 year. It means that even if we could develop technology capable of sending messages at the speed of light, the time it would take for those messages to traverse the vast distances between stars would still be incredibly long. For instance, Proxima Centauri, the closest star to our solar system, is about 4.24 light-years away. A message sent there would take over 4 years to arrive, and any reply would take another 4 years to return. For example, a message sent to a star system 1,000 light-years away would take a millennium to arrive. This means that any form of communication with civilizations in such distant star systems would be a slow and arduous process, spanning generations. Any response would take another millennium to return to Earth. This delay makes real-time conversations impossible and requires us to think in terms of centuries rather than seconds when considering interstellar communication. This effectively rules out the possibility of real-time conversations with extraterrestrial civilizations. The vast distances and the finite speed of light mean that any exchange of information would be a slow and deliberate process, requiring patience and long-term planning. We must accept that any communication across interstellar distances will be a slow and deliberate process. Scientists and researchers are already considering how to send messages that could be understood by future generations, both on Earth and on distant planets. Despite this limitation, the speed of light also offers a glimmer of hope. It provides a consistent and reliable means of transmitting information across the cosmos. While we may not be able to have real-time conversations, we can still send and receive messages, sharing knowledge and discoveries with potential extraterrestrial civilizations. While it may not allow for instantaneous communication, it does provide a reliable means of transmitting information across vast distances. This opens up the possibility of a cosmic dialogue, albeit a slow one where we can exchange ideas and learn from each other, even if separated by light years of space. Section 4. Whispers on the cosmic winds, radio waves and laser beams. Given the limitations imposed by the speed of light, what methods of interstellar communication might we employ? Currently, the most promising candidates are electromagnetic waves, particularly radio waves and laser beams. Radio waves have several advantages for interstellar communication. They can travel through the interstellar medium with relatively little interference. We have already developed sophisticated technology for transmitting and receiving radio signals. Lasers, on the other hand, offer the advantage of higher bandwidth and more focused beams, potentially allowing for faster and more efficient communication. However, lasers require more energy to transmit over long distances and are more susceptible to atmospheric distortion. Both radio waves and lasers have been used in various attempts to search for extraterrestrial intelligence or SETI. While we have yet to receive a confirmed extraterrestrial signal, these technologies remain our best hope for establishing contact with other civilizations. Section 5. Beyond the Horizon. Quantum entanglement and gravitational waves. In this chapter, we delve into the fascinating realms of quantum mechanics and general relativity, exploring how these two groundbreaking fields intersect and what they could mean for the future of interstellar communication. As we continue to explore the frontiers of physics, new and even more exotic possibilities for interstellar communication emerge. The universe is vast and filled with mysteries, and our quest to understand it leads us to consider some of the most mind-bending concepts in science. Two such possibilities are quantum entanglement and gravitational waves. These phenomena, though rooted in different branches of physics, offer tantalizing glimpses into how we might one day communicate across the stars. Quantum entanglement is a strange and counterintuitive phenomenon where two or more particles become linked. This linkage is so profound that the state of one particle is directly connected to the state of another, no matter how far apart they are. They share the same fate, even when separated by vast distances. Imagine two particles, one on Earth and one on a distant planet, reacting instantaneously to changes in each other. This defies our everyday experiences and challenges our understanding of space and time. Any change to one particle is instantly reflected in the other, regardless of the distance between them. This phenomenon, often described as spooky action at a distance, was famously debated by Einstein and remains one of the most intriguing aspects of quantum mechanics. This seemingly instantaneous connection could potentially be harnessed for communication. If we could control and manipulate entangled particles, we might be able to send information across vast distances in the blink of an eye. However, there are significant theoretical and practical challenges to overcome before quantum entanglement could be used for interstellar communication. The fragility of entangled states and the difficulty in maintaining them over long distances are just a few of the hurdles scientists face. Gravitational waves, ripples in the fabric of space-time caused by the acceleration of massive objects, offer another intriguing possibility. These waves were first predicted by Einstein's theory of general relativity and have only recently been directly detected. Unlike electromagnetic waves, gravitational waves are not hindered by interstellar dust and gas. This means they can travel vast distances without being absorbed or scattered, making them ideal candidates for long-range communication. They could potentially carry information across the universe with minimal distortion. The ability to send messages through the very fabric of space-time itself opens up exciting possibilities for communication with distant civilizations. While we are still in the early stages of understanding and manipulating gravitational waves, their potential for interstellar communication is undeniable. The future may hold technologies that allow us to harness these waves, enabling us to reach out and connect with other intelligent beings across the cosmos. The journey to this future is filled with challenges, but the rewards could be beyond our wildest dreams.